We're going to begin with group 4, right?
Yes.
Okay.
Howdy, everybody.
Howdy.
My name's Aiden Campworth. I'm with Team Meteor Run. We worked on this disaster robot challenge. We are here to present our robot and show you what we've done this past week.
Hello, I am Jack. I'm going to the 7th grade. I go to the Briarwood, and I'm the electrical mechanical for disaster meteorite.
Hi, I'm Case Alexander. I'm going into 10th grade at Logos Prep, and I am the electrical or software engineer for our team.
Hi, I'm Sammy. I'm going to 7th grade at Logos Prep, and I was a mechanical engineer for our team.
As I've already introduced myself, I am Aiden Campworth, and I'm going into 8th grade at Logos Preparatory Academy.
We accomplished some pretty nice things while at the camp. We built a robot while using teamwork, and we have a nice presentation. And we made sure that each team member knew what they were doing. So we made a good robot. Pretty much. And we coded using basic programming. I've never learned about binary code before, and I also never used a calculator to run a robot, which is pretty cool. And I also have never made a robot that could go to the moon, which is pretty cool. And I've never used a TI calculator, specifically a TI Inspire. And I've never learned about an H-bridge or, yeah.
Okay, so I have never programmed a TI Inspire calculator before. I've never even used one before. This is also the first time I've ever programmed a robot using the basic programming language. And this is the first time I've used a dual H-bridge as a motor controller. Okay, which a dual H-bridge is an electrical circuit designed to allow you to easily control motors and allows you to control and make them run in either direction. This is also the first time I've used the TI Innovator system or any of the Launchpad products.
I have never coded with TI Inspire or the TI calculator before. I have also never heard of an H-bridge or the circuit board. I have also never created a system to control a robot, and I never built a robot in general before.
I've never knew about binary or hexadecimals. I thought it was a completely different language, which it is. It's easy once you get it. You have to learn the basics and then it becomes easier, just like the robot. We built the robot. I've never really done that before. I mean, we get part kits. Here's step 1, here's step 2, kind of like Legos, okay? I've never really worked with TI calculators either. They're pretty interesting and pretty high tech. You can calculate, you can program, you can save documents, you can store documents. It's pretty cool, and I've never really built a robot for a large company. I've done it for like small competitions, but nothing on this scale.
So what we enjoyed. So we liked learning about the new software for programming the TI Inspire calculator. And we liked learning how to assemble this articulated robot. We liked learning how to have to collaborate with other people on our team through miniature teamwork exercises throughout the week. We also liked having to learn how to help each other with our tasks. We liked learning how computers speak to each other through binary. We like the leadership opportunities that were given to us as a program by having to do each of our independent roles. And we liked having to talk with each other, learn, finding out about what each other are doing so that we can make a finished product.
Our overall improvements that we want to be made are have shorter on the lessons we take, improve the layout of the robot, have the whole team change with each other, like the jobs, longer days or shorter days and more weeks to work on it, and variation in the robot designs.
Thank you.
Okay, ready? Gig 'em.
Welcome Team Harambe. Our name was inspired by the events that occurred at the Cincinnati Zoo.
Team members, hi, my name is Josh Kunst and I was the system integrator.
I'm Morgan Yop and I was in charge of the electronics.
I'm Nick Kuntz and I was in charge of mechanics.
I'm Blake Alley and I was in charge of software.
So I'm going to talk about the building process. So Morgan assisted me in assembling the frame. So we got these metal rods and other 3D pieces and pretty much put it together. So we attached the legs by wiring motors and installing wheels. Josh, then the system integrator, bent the sled with the heat gun and attached it to the frame so that the calculator could be attached to the robot.
Alright, now this is where I kind of helped in the electronics part. So first I wired the H-bridge to the motors and the innovator hub. So we had to wire the motors through the legs and then attach it to the hub. Next I installed the battery pack to the bottom of the sled and wired that to the H-bridge as well. Next, I attached the TI Inspire to the top of the robot on the sled using Velcro. And I connected sensors with the 3D printed slab, which you can see on the front of the robot, to the sled. Now, I had to wire the sensors to the innovator hub via digital inputs 3 and 4, and that concluded the electronics. Now, we have a few clips of the testing that we did.
But apparently Windows 10 doesn't like my video. Okay. Sketch.
Team accomplishments. So I'm just going to start out with my accomplishments first. So I managed the team and made sure we got everything we needed to get done. I helped fabricate the sled and bend it so it fits on the frame well. I helped create the blog and the presentation, which you're watching right now. And I participated in data collection to make the robot as good as it could be. And we contributed to documentation and answered STEM knowledge questions and equations.
Alright, so Nick and I both built the frame. I assisted him in that. I led the fabrication of the electronics, so that's wiring the motors and sensors to the H-bridge and innovator hub. I also had to test the motors to make sure they're all going in a pattern that was fit for the robot. I also integrated the sensors in the H-bridge and connected the motors via wiring. I also participated in data collection, so we had to collect like different speeds for just testing that we had to do. And I also contributed to documentation by taking pictures and writing some of these bullet points. I also entered STEM knowledge questions, which we were given a lesson earlier in the week, and I had to answer some that we were tested on.
Okay, so I built the frame of the robot so that Blake could then put the software in. I assisted in the electronic assembly. I participated in data collection by taking pictures.
So I led the software development for our team. I programmed the sensors to control the motors, which is analog and digital, is how the H-bridge is configured. I created the code to control individual LEDs and motors. This was before the testing stage of our final robot. I answered STEM knowledge questions, participated in data collection, by writing down speeds when we were collecting our data for tweaking of the robots, and I contributed to the documentation by taking photos and video, and I'm going to skip that last one because you didn't see it.
So what we never done before, we have never been to TI or seen what they do, and we've never constructed a disaster or seen them.
Also, we've never interacted with the TI Inspire calculator, so it was our first time using that, so those were pretty cool to use. We also constructed a robot controlled by the TI Inspire, which has never been done before, so that was also really cool.
We have never used a TI innovator to program a disaster robot, and we have never taken a course with Texas A&M.
We've also never been instructed by a college professor or coded in hexadecimal or binary before.
So we thought that the best part was reaping the rewards after all the hard work that we did, and just seeing the robot follow the line like we programmed was just awesome.
The best part overall is receiving the Medal of Honor for winning the race. Okay, recommendations. We wish that all jobs had a bigger role in constructing the actual robot. For instance, I was the manager, so I kind of wish I had a bigger part in constructing it, but that's okay, it was still fun.
We would prefer that we'd have fewer lectures. The lectures are great, but we wish we would have more time programming so that we can make our robot more efficient.
And also assemble the robot with your team all together instead of separately, and also not with other teams. I think that would help with the efficiency of programming and building.
All members of Team Harambe would like to give a huge thanks to Texas Instruments for all they have done for us this week. We thank you for letting us use your facilities and for supplying the parts that we needed and teaching us all about what you guys do at TI. We also would like to thank Dr. Morgan and all the Texas A&M students for putting on this camp and teaching us all this and helping us build it, which we could never do without them. So thank you, guys.
Okay, gig 'em, ready?
Well, good afternoon.
Good afternoon.
We're Team Aries, and this project was made possible by the kindness and knowledge of our outstanding Texas A&M and TI mentors. So, meet the team. Meet the team. Unfortunately, Mr. Dylan Halim, who was our electrical team member, is not able to join us today because he has a tournament that he's going to. But we have Elijah Wang Chen, who was our software guy. We have Tucker Yap, who was our mechanical guy. And I was a systems integrator and communicator. Accomplishments. I'm going to read Dylan's accomplishments because he's not here. He said that this camp was challenging but fun. He does not say that. He says, this camp was cool. It taught me how to use circuits to connect motors. It was actually pretty fun to see how my electrical contribution to the team worked in with everyone else's parts. I felt like I was a vital part of something bigger, a great disaster. Now we have Tucker Yap.
This camp was challenging but fun. It was fun to build the robot. Some parts of it were tedious, but when I finished those hard parts, I felt accomplished. I had to use my hands to get all the intricate pieces of the bot together. I got to use extraordinary tools. I like robot mechanics. Woo!
So camp was exciting and I liked the software job. It made me think a little and I realized that I kind of liked coding, even though it was hard. I learned how to program a robot and do all sorts of things. It changed the way I took on challenges. And yeah, programming opened up my brain and this camp was good and it taught me a lot.
My accomplishments, woo! First, I'd like to thank Mrs. Wicks and the whole A&M TI team for putting this whole thing together and being so patient with us. Being the communicator was no simple task. I had to study blogs and put together this presentation. I also had to integrate together the jobs of my teammates. I was the leader in a sense. This camp taught me how to be a better and more effective leader, and for that I'm grateful.
Oh, so I learned how to use basic coding, and that's pretty much it. And this engineering training camp has allowed each member of our team to experience things in which we have never done before.
And I used a TI Inspire for the first time, which is pretty cool.
Dylan Halim says that he had never really worked with wires before the camp. And then something I had never done was work with a heat gun, and that was like really amazing because we had like this stick of wood like this. It was just like a stick of wood. And so one of our mentors would like go like this with a heat gun, and then we like bent the stick of wood and made everybody feel like Superman. It was like so. So favorite parts. Now we're all going to talk about our favorite parts. Elijah?
Well, I liked how we could, use computers and just have a fun time.
Tucker?
My favorite part was finishing the frame of the body and finally getting the robot to complete the track.
My favorite part was learning from our TI and A&M mentors about all the different aspects of engineering, and they really gave us like a full picture of what it's like to not only be an engineer, but be an engineer here at Texas A&M. Our ideas for improvement. I'll start off by saying that I wish that we could have had more time to learn our team members' contributions to the team so that we could get like a bigger picture of what like the electrical or the mechanical person was doing. I also thought that we could have had better operating tablets because sometimes the keyboards on them were kind of funky. Yeah.
I kind of hope that we could have more flexibility with the design, not everyone having the same design of the robot, although the programming is different. And also more freedom in like different languages, like maybe not just basic, maybe Java, stuff like that.
And I think we should have a more selection of wheels, and which leads me into my next point, like an off-road track, so you could have bigger wheels like on the Ghost.
Although we do have ideas for improvement, we do think that the overall camp was amazing. And here's a video for y'all's viewing pleasure.
It's okay. It's just don't play.
Alright, the video's not gonna work, so thank y'all for your time and Giggle Aggies.
That's the weird thing. It's supposed to be that, but then it just does this.
Okay, Gigamax.
Good afternoon, everyone. Today, me and my team, Team Armageddon, are here to announce our team and what we've been doing for the past week. Our team members are Shauna, who works in the electrical department, Catrielle, who works in the mechanical department, Sarabi, who works in the software department, and I'm Anjali, and I work in the communications and system integration.
So one of our first accomplishments was building the frame of the robot. We used objects such as wires, wheels, metal parts, 3D printed parts, etc.
So I was a software person, so we used calculators and TI Innovator hubs to code our projects that we did. So first we built a circuit using LEDs, switches, and we also coded something with sensors, and then we coded something so that the robot will go in a straight line, and finally for our result we coded something so the robot would follow on a black line.
So some of our accomplishments were that we used a heat gun to blend the sled and different lengths and angles to put our calculator base on.
One of our accomplishments was that we learned about the H-bridge, which controls the robot from the innovator and the calculator. Your H-bridge provides the power needed to move the motors.
Some other accomplishments we have were we attached the sled to the frame. So that yellow piece you see on our robot, that's our sled. So we attached that to the frame, and then we attached the calculator case with Velcro onto the sled and slid the calculator in the case. Also, to build our frame, we attached 3D printed parts, those little black things by the wheels, to the metal rods.
So one of our other accomplishments were that we tested the motor wires on the wheels, to see if there were 12 volts, and if they were, then it was good to power our robot.
So on Tuesday, we had a mini lesson that taught us about the binary number system and the hexadecimal number system. So basically, the binary number system consists of two numbers, zeros and ones. And then the hexadecimal number system consists of numbers 1 through 9 and letters A through F. Another accomplishment we had is that we tested the robot on a testing track, which looks much like what we have over here. It was this white sheet laid down and there was a black line on it. And so basically we programmed our robot to follow this black line and not go off to the white.
One of our new experiences was we made an LED light blink using a TI calculator. Another thing we did was we bent plastic with a heat gun. The instructor, he got this heat gun and he went back and forth on the plastic and we bent it a little bit. And then we flipped it over on the other side and we bent it a little less.
So some of our new experiences were we made a circuit with LED and making it blink using a calculator. We bent plastic using a heat gun. We used a hand drill for the first time. We learned binary and hexadecimal math, and we learned how to write a block.
So some of our favorite things that we did was we liked how much we were challenged by it and how we got to learn different things through software, mechanical, electrical, and writing blogs and everything.
So some suggestions we have for next year is we'd like more time per day, or maybe like have it stretched out over 2 weeks. So more time to program, build, make sure everything's perfect. We'd also like it if all of our team members work together, because a lot of times we were separated. So like if we could all work together, that'd be really great.
I would just like to say thank you, parents and grandparents and brothers and sisters and aunts and uncles for coming, and just we appreciate you and all you've done for us, and our instructors for teaching us what to do, because if you didn't, we wouldn't have built that. So, thank you.
Okay, ready? Gig 'em.
Okay, we have an official timekeeper somewhere. Oh, I want to introduce you though. You're the official timekeeper. If he doesn't, that's fine. Right now, you're the official timekeeper. Okay, so we're going to put down the Coke bottle right behind the robot.
You stepped on it.
Thank you, Sammy. Ready, set, go.
I feel like there should be some cheering.
No, there couldn't.
Let's go.
Slow and steady. Wow. First turn coming up. Can they negotiate it?
Of course I can.
Oh yeah, baby. We have a mechanical system, an electronic system, a computer system. Oh, wait a minute.
Like you want to put it down and start it up.
So that's where you want to go, huh?
Everything looks pretty good. Does it look pretty straight?
Ready, set, go. Looking good around the first turn. Hairpin, they're coming up too. And they negotiate.
Same spot. Same spot.
This wall is black.
Pick it up, John. Pick it up.
Mark, set, go. Looking at a different strategy here.
Faster. One.
Now to the curve.
And they make it around the turn. Looking good so far. Uh-oh. Look out. Can they make it? Can they make it? Oh, yeah. Nice work, gentlemen. Sammy, I thought you were gonna just collapse right there. Whoa. All right. Up. Here's where we've had problems. Can they make it around this turn? When the bottle goes down, timekeeper.
One. Knock it down.
Whoop, 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 whoop.
Can I make it? Can I make it?
Yes,
Come on.
Set. Go. Okay, they're off. Taking the hard part first. What a strategy. You can't touch it, Kathy.
I thought they were supposed to be in the
They're girls. They don't listen. Up, up. Oh. Bring it all together. Mechanics, electronics, software, integration. What a team. There we go. I've been told they plan on jumping up and down if the robot gets stuck.
Hyperspeed.
Come on, Armageddon. Oh. Look at that. Yeah. Yeah. Are you going to make it? You see the Coke bottle? It's almost there. Will they make it? Will they make it? Will they make it? Yeah! Timekeeper, are you ready? On your mark. Set. Go. Okay, get on the inside of the track. Inside of the track. Disqualified. That's a 10-second. Each team's built its own control algorithm and decides what they're going to do, both in speed and based on what the sensors give them, what the robot is actually going to do as far as turning or backing up.
I got the same thing I had last time for this one.
I'd say you're beating your first time. What do you think? Hush falls over the crowd. Looking smooth. Timekeeper, are you there? Yep. Oh, no. Yes! Okay, let's see what we got. Set, go. And they're off. Can they make up 10 seconds?
Yes.
Can they take over first place?
Not if it doesn't.
It's gotten into the oscillation.
Come on! What are you doing? It failed. It's stopped right there.
That's the summary of our robot.
This is our robot in action.
What?
Okay,
Go, Aries.
Am I in the way still? No. But it's what
low and steady.
Talk to it, Sam.
Where's the glare at? You're just telling me what it is, right?
What do you think, Tucker?
Do you think we start on the curve? I'm gonna stay out of the way.
You're not even gonna look?
Good service.
That's pretty straight.
So straight.
So far, the straightest straight I've seen so far with the rest of the robots.
Did we get points for that? Do we get points for straightness? Oh no, this is a turn. Come on. Make the turn. Make the turn.
Yeah. Get around it. Yeah. Come on, baby. Talk to it, Eric.
Go, 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 go! Gotta get the turn. Get the turn, get the turn.
No, we got it.
Gotta get in time, gotta get in time.
Where's the bottle?
You can see the Coke bottle.
That's like worse than
I think they're gonna make it. Go! Come on, baby. There we go. Now we're picking.
It's not like.
Talk to it, Tucker.
Anything else y'all want to change?
Put it on the line. Put it on the line.
You definitely want it on the line, man. Don't start that far out. Have one that's on the line. On your mark. Get set. Go.
And they're off. The last team.
Imagine if it knocks it down
They can
right
beat
now.
Armageddon.
Imagine if it knocks it down right now.
Can they do it? You gotta come be my student. Look out, look out. Come on, Harambe.
Everyone else is like Are we gonna be to infinity?
And they get around the big turn. Working on an infinity right now. Will they come back? Have they made the proper adjustments? Done the engineering analysis? Looking good. Looking good. Whoa.
I dare you.
Don't you dare. Don't you dare. You will be disqualified.
I'll pull it back a couple feet.
Coke bottles in sight.
Oh, we definitely got time. We've got time.
There it is. Can you see it? Uh-oh. Whoa. Whoa.
Get it. Get it.
Come on.
Come on, beat him. Come on.
I don't care.
Come on.
Third place in the disaster competition is Team Aries.
How did I know that?
You did a fine job. Remember, there are 4 different events. Congratulations, young man.
Right, now the big drum roll. Everybody's excited. We'll reach for the word. Down to this. The winning team was Team Harambe.
Yes.
Hey, are you still recording? Yeah. Let's go!
What's up, Gracie?
Deal with it. Deal with it.
Replay back to that. Me.
Get a macro of the side. Change the world.
You don't want to get off?
Yeah, change the world with this morning.
I don't think she knows.
So weird.